Hello one and all, and welcome to David's math class. In this video I will show you how to solve a problem from the Romanian Math Gazette. We are talking about problem 28239, which states that if A, B, C are complex numbers and their radius in polar form is equal to 1, then show that this expression a squared minus 1 times b squared minus 1 times c squared minus 1 times I plus a squared plus 1 b squared plus 1 c squared plus 1 all over ABC. A is real and B is smaller than or equal to 8. Alright, so how do we go about this? Well, first of all, notice you have complex numbers and multiplication. We know that if we write polar numbers, complex numbers in the polar form, it will be easier to solve this expression because we all know that cosine of alpha plus I sine of alpha times cosine of beta plus I sine of beta is equal to cosine of alpha plus beta plus I sine of alpha plus beta. So yeah, multiplication will help us here, which is why we have to consider the complex numbers ABC to be written in polar form. So consider A is equal to well, as you notice here, the radius of A is equal to 1, so we can just write this as cosine of alpha plus I sine of alpha. B is equal to cosine of beta plus I sine of beta, and C is equal to cosine of gamma plus I sine of gamma. We can do this because each of the numbers' radius is equal to 1. Now, we have a squared minus 1. We want to write this as a complex number in its polar form so that we can perform the multiplication. So what we'll do is consider Z a complex number such that Z is equal to cosine of theta plus I sine of phi plus I sine of phi, where phi is a value in between 0 and 2 pi, 0 included. And we'll just also for simplicity we write here as we consider sorry, just have to write this down. We consider alpha, beta, gamma to be in the 0 to pi interval, 0 included, as well. So let's see, what is z squared minus 1? Well, first we square this, which gives us double the argument. So we have cosine of 2 phi plus I sine of 2 phi minus 1. Recall that cosine of 2 phi is equal to, well, that will be 2 cosine of phi squared minus 1. Yes, that's right. And now sine of 2 phi, sorry, is equal to 2 sine of phi times cosine of phi. So in the end, this expression turns into z squared minus 1 is equal to notice again, we have cosine of 2 phi is equal to 2 cosine squared of phi minus 1. So that gives us cosine of 2 phi minus 1 is equal to 2 cosine squared of phi. Alright, wait, something's wrong. No, this is a plus right here, so that will be a plus. Really, there's a problem with the formula we just used here, because cosine, we need cosine of 2 phi minus 1. So what we instead do is write this as 1 minus 2 sine squared of phi. That's what we do, and that means cosine of 2 phi minus 1 is 2 sine squared of phi. So z squared minus 1 will be 2 sine squared of phi plus I times 2 sine of phi cosine of phi. Now we'll just erase a bit so that we have space. I'll erase this as well since my board is very small. We'll just remember everything we have written. Now, actually, let's leave this. Alright, so next thing we do is give a factor of 2 sine of phi, and we get z squared minus 1 is equal to 2 sine of phi times, let's see, sine of phi, oh sorry, forgot to put a minus, here's a minus, here's a minus. Alright, so it's 2 sine of phi minus sine of phi, and that's plus I cosine of phi. Alright, now let us think, what number has so remember, we have to have a cosine of phi of, no, not phi, because we already used phi, cosine of theta right here, and then an I sine of theta. So let's take a look at the trigonometric circle. So, if we have the xy plane, the complex plane, and a circle right here, the trigonometric circle, notice if we have a number right here, which is cosine, sorry, I just have to, cosine of phi plus I sine of phi, then we have to look at this, I'll make this green, and this will be yellow. And now we need to have a number whose cosine is minus sine of phi. Notice this is sine of phi. So if we have minus sine of phi, then we would have something like this. The green part would be here. And now we have the sine of theta equal to cosine of phi. So really this green part should be above, because it has to be positive. Alright, now I'll draw this in red for you. And notice this is theta, and because we have the same lengths, two lengths and a right angle, I just draw it right here, right angle here. This means that these two triangles are congruent. So let's see, this angle right here is theta, this angle right here is, phi, it's phi. And now this, let me draw it in blue for you, this angle is pi over 2 minus phi. So in the end what we get is, let's take a look. So we have pi over 2 minus phi, and then plus, I'll draw this in, theta is equal to pi. And really we get this, we move this here, it's pi over 2, minus theta goes on the right, and we get theta is equal to pi over 2 plus phi. Alright, we'll be right back. Okay everyone, we are back. So we have theta is equal to pi over 2 plus phi. So we'll rewrite this, let me just erase this. So z squared minus 1 is equal to 2 sine of theta, phi, times cosine of theta plus pi over 2 plus I sine of theta plus pi over 2. And this is our trigonometric form. Next up, we have z squared plus 1. So we get, let's see, that's sine of, no, cosine, sorry. So it's cosine of 2 phi plus 1 plus I sine, I sine of 2 phi. Alright, so now we have cosine of 2 phi is equal to 2 cosine squared of phi minus 1, and cosine of 2 phi is equal to plus 1 is equal to 2 cosine squared of phi. And of course we also have sine of 2 phi is equal to 2 sine of phi times cosine of phi. So what we get is z squared plus 1 is equal to, let me just see, cosine of this is 2 times cosine squared of phi plus I times 2 cosine of phi sine of phi, and this is equal to 2 cosine of phi times cosine of phi plus I sine of phi. Alright, so now we'll simplify these forms, but first we'll erase what we no longer need. Okay, we actually needed that, so that kind of sucks, but it's alright, we just rewrite it. So we have z squared plus 1 here, and z squared minus 1 was equal to minus 2 sine, wait, it was a minus, sorry, it was a plus, it was 2 sine of phi times minus sine, no, let me just write this in its trigonometric form. So it was cosine of phi plus pi over 2 plus I sine of phi plus pi over 2. Great. But notice, we added pi over 2 here. And what number on the trigonometric circle has argument pi over 2? It is, yes, you guessed it, it's I. And that means really what we have to do is just multiply this by, so it will be cosine of phi plus I sine of phi times I. So we rewrite this. It's 2 sine of phi times I times cosine of phi plus I sine of phi. That is, yes, you guessed it, it's z. And now 2 cosine of phi times this, it's 2 cosine of phi times, you guessed it, z. So that's what we have. And now things become much more simpler. Alright, so we're back and we have written this out. Our expression becomes, now it's a squared minus 1, b squared minus 1, c squared minus 1. That will be 8 sine of alpha, sine of beta, sine of gamma times I cubed, because it's 3 times I, times I fourth. That will give us really I fourth is 1. So we get rid of the I term, and now we multiply by A and then B and then C, alright, over ABC, and then we had A squared plus 1, B squared plus 1, C squared plus 1, which will give us 8, wait, let me rewrite this, oh my god, this whiteboard just gets really black after a while. So 8 cosine of alpha, cosine of beta, cosine of gamma, all over A, B, C. And this multiplied by A times B times C. Alright. And since these terms cancel out, we're left up with 8 times sine of alpha, sine of beta, sine of gamma, plus cosine of alpha, cosine of beta, cosine of gamma. Alright, and we have to do one more thing. Since this number is a real number, we now have to prove it's smaller than or equal to 8. And we'll do this the following way. So notice we sine of phi is always smaller than or equal to 1. And cosine of phi is smaller than or equal to 1. So really, what this expression tells us, what we can derive from this expression is that it's smaller than 8 times sine of alpha, sine of beta, times 1. So we just leave it like that. We just get rid of the gamma term, since it's, sine and cosine are smaller than or equal to 1 for any angle. And then cosine of alpha, cosine of beta, and this is, you guessed it, 8 times cosine of alpha minus beta. And that, folks, is greater than 8 times 1 is equal to 8. So, that concludes our proof. Thank you for watching and see you in the next math class.